Hello, everyone. I'm not here to go over the study guide, so hopefully you have followed the directions and figured out that you have this video made for you. We're going to go through the whole study guide. Um, just me talking, though, so you listen carefully, pause, rewind as you need to get stuff down if you need it. Okay, first question. What are the levels of organization and order? This is talking about the primary producer, the primary consumer, the secondary consumer, the tertiary consumer, and the quaternary consumer. So we did that with the food webs and food practice Wizard Me. You might want to go look at those words again if you need to. What kinds of organisms are primary producers? They are autotrophs, meaning plants, or chemotrophs, things that can capture energy from either the sun or from chemical production. Most primary producers are doing photosynthesis. How are herbivores and carnivores alike? Both of them must eat to survive, so they are both heterotrophs. A lion kills and eats a zebra. This lion is a consumer and also a carnivore. Only 10% of the energy is passed on to the next trophic level. How is the other 90% lost? Is lost as heat energy. Okay, question 7 is all looking at this diagram here. Box number 1, that's going to be your primary consumer. 1 is primary producer because 2 is primary consumer. 4, tertiary level consumer. And everything dies, so 5 is decomposers. Everything dies and must be broken down to further the nutrients to go back in the soil or the air or whatever. 8, why can't producers in some ecosystems make an unlimited supply of organic material? Well, there's limiting nutrients in every ecosystem. Sometimes, like in more northern regions, it's going to be the temperature and the amount of sun they get. Sometimes it is the amount of nitrogen or phosphorus or whatever water available. So that is why there's a limit to the amount of organic material. Primarily, the primary producers can only make so much for that environment. 4 examples of biotic factors in a forest. So if I'm looking at a forest, trees, the shrubs, the rabbits, and the owls would all be examples of biotic factors in a forest. What would the abiotic factors be? Well, the stream, which is water, the air, the rocks, and the soil would be 4 examples of abiotic factors in a forest environment. Okay, here we have a little story. There's a fire. The deer have to move. Why are they moving? This change of behavior is due to a change in their biotic factors because the deer can't eat ash. So it is a biotic factor. The base of all ecological pyramids, well, if I scroll down here, here's my ecological pyramid, is going to be producers. So remember, on the test, don't be afraid to go back scrolling through and looking for pictures or diagrams that might help you in your short answer. So 12 was producers. 13 says a 4th level consumer if the producers provide 34,000 calories of energy. Well, if I go here, The first level consumer gets 3,400. The second level consumer gets 340. The third level consumer gets 34. That means the fourth level consumer only gets 3.4 calories, because 10% is lost every time, or 10% is only what goes in, and 90% is lost. What you're doing is just moving that decimal place, because you only get 10% of that energy. So it's the same as dividing by 10 or moving the decimal place one level. If it helps to write it out, I would do that. The first level consumer equals 3,400. And then just keep going and write out how you figured out. That's especially helpful for me if you make a mistake somewhere. I will understand that you moved the decimal place over twice somewhere and you get at least partial credit for the answer. In ecosystems, voles are preyed on by snakes and owls. If we add hawks, who will also eat the voles, what is going to be the likely addition of the hawks? Think about the food web game, the food fight game. What happened when you added another predator to your primary consumers? The voles are going to go really, really low. But then the snakes and the owls are also going to decrease, because you have to balance the whole ecosystem back out again. And depending on who's a better predator, you may end up losing one of the predators. Or if all of them are very good predators, they wipe out all the voles, then you're going to have a problem because they have nothing to eat, depending on what else is in the ecosystem. So think about that food fight game and how everything balanced according to what was going on within the food web. How are the living creatures in an ecosystem linked? By what they eat. Again, think of the food fight game. If we wipe out producers, then we're going to wipe out the first primary consumers, and so on and so forth. If you wipe out or damage one thing, everything else has to balance out. Why are the food chains sometimes short? Why do we only get sometimes the 3 different ones? Like the grass was eaten by the antelope and the antelope's eaten by the lion? Well, because there's only so much energy available in each ecosystem, depending on the nutrients and the abiotic factors of that ecosystem. Okay, this should be pretty simple. Just follow the arrows. Make sure when you're writing it that you write arrows. So on a computer, I would just do the dash and the little arrow shape thing. Something so I know that you know. So on the Chromebook here, if I do 2 dashes and then the arrow, it actually puts in an arrow for me. So one of my chains could be tree to deer to mountain lion. So I misspelled deer. Mountain lion. Deer. Okay, same thing. Find your grass, or go from tree to caterpillar to robin to fox. Or you go from your grass to grasshopper to frog to snake to fox to mountain lion, evidently. So make sure you have at least 3 organisms in your chains. Make sure your arrows are pointed in the right direction. And make sure you are looking at that food web. It does not matter if you know that deer eat grass. That's not what the food web says. So make sure you're looking at that picture and diagramming only what is drawn in that web. Okay, so using the food web, how many energy transferring steps is the sun from the robin. Okay, so this is a trophic levels, in other words. So the tree is the first trophic level. The caterpillar is the second trophic level. So the robin is the third trophic level, and that's exactly how I would put it. The robin is the third trophic level away from the sun. Which population in the above food web would be most directly affected by a fungus that kills the trees? So, most directly. So, if there were no trees, what's going to happen? Well, the deer only eat trees, according to this food web. So, they are going to be the first to be impacted. The caterpillar, slightly impacted, but he also eats grass. So that means he would have to eat more grass, which could affect the rabbits. But when it says most affected, don't overthink it. Look for the animal that eats only from that one thing, or animals. If there's two animals that eat only from that one thing, then that is how you put it. It's the ones that are going to be affected first, because the deer only eat from the trees according to this food web. That is why they are being most directly affected. Besides the trees, obviously. Okay, in the above food web, does the hawk get more energy if it eats the rabbit or the snake? The hawk. Okay, so if the hawk eats the snake, how many steps does it have to go through? Here's one trophic level and two trophic levels to get to the rabbit. So the rabbits is only a two-step process. The grass to the grasshopper to the frog to the snake to the hawk, that's a lot more trophic levels. Remember, you're losing 90% of energy from that grass to the rabbit and 90% of that energy from the rabbit to the hawk. That's even more energy lost if I have to go through more trophic levels. So it would get more energy by eating the rabbit because it keeps the 10% rule. 90% of the energy was lost as heat, and the rabbit is closer to the primary producer than the snake. And you can go through, the rabbit is only one trophic level versus the snake, which is 1, 2, 3 trophic levels, or at least 1, 2 trophic levels, depending how you're going, what the snake's eating. Explain the roles of photosynthesis and respiration in the carbon cycle. This is where the Wizard Me with the carbon cycle practice could come in handy. So if you happen to have done that, great. If you haven't done it, why don't you want to go? Go to Wizard Me. Okay, go back. Open interactive worksheets. I'll figure it out. Let's pause. Okay, I managed to get the Wizard Me pulled up. So if I look at this, I can see I have one of those carbon cycle reviews here. It says, how are photosynthesis and respiration played out in the carbon cycle? Well, if I look at this, photosynthesis is pulling carbon dioxide out of the air. It's putting it into a sink, right? A sink being something that stores the carbon. So photosynthesis takes carbon out of the air. Respiration puts carbon into the air. That's all it's asking there. The removal of which organisms in a food web will cause the most widespread destruction and why? Well, if I look at a food web, who's going to cause the most widespread destruction? Well, if you wipe out the plants, right? If I wipe out the plants, everyone else is going to be greatly affected. What types of organisms recycle all nutrients? What types of recycle all nutrients in an ecosystem? Plants and decomposers. Decomposers are going to break it down, and then the plants put it back into the ecosystem. I'll put it that way. Okay, here I have a pyramid, an ecosystem pyramid. What if someone released 100 extra toads? What's going to happen, and would the ecosystem be able to survive? Well, that's going to depend how you're going to defend it, right? How many animals are here? I've added an extra 100 animals here. That's going to greatly increase competition between the birds, the mice, and the frogs. It's going to greatly decrease the primary consumers. So the question is will the ecosystem balance itself out in time? Because what's going to happen is these guys, the tertiary consumers, are going to get nice and fat by eating things that the extra toads, and then the quaternary consumers will be able to eat these. So is the balance going to get fixed fast enough? It's only 100 extra toads. I would almost need to know how big is this particular ecosystem. A small one, like a pond area, 100 extra toads is going to be a problem. And maybe it could cause the whole system to crash because maybe the frogs wipe out all of the primary consumers, and then you have nothing for these guys to eat, and then nothing for that one to eat, and then everyone's going to have to find a new niche. They're going to have to leave or die, right? Because animals can only do three things. They can adapt, they can move to where it's a better location, or they die. You are born with adaptations. The snakes are not going to start eating grass. Can't happen. If these guys are already wiped out, the snakes can't even eat the mice. I guess those are rats. I don't know. Anyway, so adaptations means you either have it or you don't have it. You can't decide you're going to become a vegetarian as a snake or as an eagle. That's not a choice they get to make. This one, because of biogeochemical cycling, nutrients are circulated throughout the ecosystem. So remember, nutrients goes in circles. Energy flows from the sun up the pyramid, and it does get lost. So energy is different than nutrients because energy is lost. 90% is lost. Only 10% moves on in every cycle. Where the nutrients, carbon dioxide, water, nitrogen, phosphorus, those are circulated throughout the ecosystem, and they may change form, but you do not lose the nutrient within that ecosystem. Okay, that should be the whole thing. Feel free to message me if you want to go over something again, or you want to know which review would help with something the best. Otherwise, we should be ready for the test tomorrow. Bye.